Earth, the only planet we know of that harbors life. But are we alone in this cosmic ocean? With advancements in technology, scientists are just starting to answer that very question. And until recently, we had no idea if there were planets outside our solar system. However, we now know that they are actually pretty commonplace inside the universe, and most stars do in fact have several planets around them, and that planetary systems are very common within themselves. So when scientists look out into the night sky, they seem to believe that life outside our solar system is very likely, and in fact more than likely, because of the sheer amount of chances there are. In our own Milky Way galaxy, there are over 100 billion stars, and each of these stars can have multiple planets, which means multiple chances for life outside of our solar system. And there are billions and billions of galaxies, which just means the numbers of possible planets out there is astronomical. Some estimates put the possible number of planets to 10 times 10 to the 19th power, which is just a crazy number of planets to be out there. And at this scale, each speck of light is not a star, but in fact an entire galaxy, just to give you a perspective of how huge the entire universe actually is. And with the recent launch of the Kepler Space Telescope, we are just beginning to uncover these planets. Kepler, taking over 2 years to complete, has been one of the most successful missions by NASA, and discovered over 700 new planets in the first 15 months of it being active, which was amazing because before this we had no idea if planets even existed outside our solar system, because they're so much dimmer and smaller than the stars that they orbit that they're nearly impossible to detect. Kepler's satellite is actually very unique amongst satellites because it focuses its gaze in one fixed location near the constellation of the Cygnus Swan, and takes the same snapshot day in and day out for years on end of the same exact position, and it does this because of its very unique way of detecting planets. So when looking for planets, Kepler either does one or two things. It will look at the brightness of a star, so as a planet passes the star, the brightness of the star will go down, and after several cycles it will confirm that the object is a planet. And what we are seeing now are what astronomers call first light, and are the actual first images of what Kepler saw as it opened its lens to the constellation of Cygnus the Swan, and are all the planets that are within its range of sight. The next method to looking for other planets is called the wobble method, which we actually analyze how the gravitational pull of the planet affects the star, and will actually cause the star to wobble a bit, and as the star moves away from us, the star will become red, and as it comes closer to us, it'll become blue, due to the Doppler effect. In our search for life, Kepler has brought us to the planet Kepler 22b. It's about 2.4 times the size of the Earth and has an orbit of 10 months, which is very hopeful. But what we really need to know is, what is it made of? It can either be a huge gas giant, or it could be a very big rocky planet that would have immense gravitational force. And to discover what the planet is made of, scientists had to compare its mass to its gravitational pull, and what they discovered was that it was much weaker than it would be if it was a rocky planet, which means it could be either a small gas giant, or more interesting, a water world that could harbor life. A major obstacle life would have to overcome on this planet is that because of its size, there would be no ocean floor, so they would have to adapt so they could stay buoyant above their planet's surface. The next planet that Kepler brings us to is KOI 2626.01. And the first thing you would notice about this solar system is that the planet doesn't orbit like what we would call a normal star. It actually orbits a red dwarf star. red dwarf stars differ from other stars because they're about 10 to 20% the size of our sun and about 10 to 20% as bright. Now what this means for the planet is that it has to get much closer to the star so it can get the same amount of heat that we would get from our sun. The planet is so close to its star that its orbit time is only 38 days compared to our 1 year. When you get this close to a star, some problems start to occur. Now, one of the main issues with a planet such as this one that is so close to its star is that the gravity from the star will actually pull harder on the side of the planet that is facing it. It will actually change the rotation of the planet so that the planet will always have one side facing the star. And this, as you would imagine, would cause one side of the planet to be really, really hot and the other side to be really cold because the other side doesn't get any sunlight. And this is a process called tidal locking, and when scientists first looked at these tidal locked planets, they didn't believe life could exist until when Kevin Hang decided to use a program on a computer to simulate what the temperature might be on this planet, and he discovered that the planet would actually be very cool in some zones, around like 25 degrees Celsius, and that's like around like 75 degrees Fahrenheit, just to give you some perspective, which is actually a pretty nice temperature, and you wouldn't that's a pretty nice day here. This planet would be able to get to these tolerable temperatures because the cold air from the dark side would lower and diffuse out towards the heated side of the planet, and then the hot side that faces the sun would the air would rise and then go towards and diffuse towards the other side of the planet. Now this interaction would also cause weather patterns and like strong winds. These weather patterns in turn would create an atmosphere for the planet, and once this planet has a stable atmosphere, it would be able to contain life and harbor life, and it may flourish in this planet. The next planetary system we'll be looking at is the KOI 701 system, and the third planet is much like the first one we looked at, and is most likely a water world. But with further research, we found that there was actually a fourth planet which we originally didn't know about, and this fourth planet is about 40% larger than the Earth, and it's smack dab in the middle of the Goldilocks zone, so we call it, which is like where liquid water can exist. Yeah, so this planet, which is now called Kepler 62f, is probably one of the most closest planets to being like Earth, and it's something that you could actually stand on, and is like the best chance for life as we know it out there in the universe so far that we've found. And it is about 1,200 light years away, so that it would take us millions of years to get there, even with our fastest spacecraft. And even if you were going at the speed of light, it would take you 1,200 years because that's the distance it is from the Earth. Just sort of already started to speculate what life might be like on this planet, and they say the best speculation is one that realizes that there's rules, and any life forms beyond Earth will be subjected to the rules of chemistry and physics. And they decided that the ocean life on this planet would probably be much similar to the one we have here on Earth, but the animals above the surface on the land would probably have to be much stronger because it is bigger than Earth, so they would have to overcome the gravity. So to get over this immense gravity, the animals on this planet would probably have much like column-like legs like elephants, or they would be much lower to the ground, like such as alligators or snakes. First started my project, I always kind of wondered what it would be like if aliens came to Earth. And the first thing you have to realize is if they came to Earth today, they would be so much more advanced than us, because if they have the technology to travel in the deep space, I mean, they're gonna be like centuries or millennium past us. I mean, if they start, like, say if they started evolving, like, to be smarter much before we did, I mean, their technology could be far past us. And what would that mean for us? Well, I mean, it depends what the reasons is. I mean, they could just be exploring the universe like what we would do maybe if we started traveling into deep space. Or, I mean, they could have been on the same track that we are now, and like their planet has been decimated by global warming. Because, I mean, if they started before us, I mean, their planet might be completely polluted or something. And so they may be looking for a new planet that they can live on. And if this is the case, it might worry us, because in biology there's a thing called competitive exclusion principle. And this what this basically states is that when two species are like competing for the same resources, that one of them eventually goes extinct, or they have to adapt or to move. Because if you are, like, say if there's two monkeys and or two species of monkeys in the same tree, one species of monkey will either push the other monkey out of the trees so that they can have the trees to themselves. And I mean, you might be like, well, I mean, we're intelligent beings, and we're kind of far beyond this. I mean, when you look at when the English first came over to the Americas, I mean, they were pretty intelligent too, and that was like only 200-300 years ago for us. And they just like, hey, Native Americans, get out of here. I mean, you guys aren't using the land properly. We're just gonna take over, and we're gonna set up our base here. I mean, and if they treat us anything like we did to the Native Americans, I mean, we might have a pretty rough time. And so movies like When Mars Attacks or War of the Worlds, they may not be so far off when it comes to predicting how we might be if aliens came to our planet. I would just like to say I hope you enjoyed watching and enjoyed my presentation.